Thank you, guys. Before I get started, because it's the last session of the day, let me ask you a question. How many of you think you're independent? Exactly, good question, isn't it? So let me rephrase the question. My question is, how many of you think you can actually make choices which you think are truly independent? That's a good question. Thank you. Independent of external factors, so which aligns with your belief system and you think you as an individual made that decision, or you as an individual made that choice.
We don't exist as separate systems.
That's a good answer. Okay, that's interesting. Anyone else? No one thinks that they're independent. Is that you think you're independent? Can you explain that a little bit more?
Well, just exactly the opposite of there being no free will. I think there is. I feel like if you have complete autonomy, I think it's possible to be objective. I mean, obviously, to an extent.
So when you say to an extent, what does that mean?
Well, I think there are obviously going to be a whole bunch of unconscious bias.
Brilliant. Thank you. So there's a word which has been mentioned called bias. We're going to talk about that in more detail. Before we go into bias, what is actually ethics? So ethics is a discipline which has been there for years, for centuries. It's nothing like a new concept. But when it comes to data science, it's getting more and more relevant, because with data science, you have an interaction between human and machine. And that's where you've got to have a lens of ethics in whatever you do, either as a data scientist or as a decision maker, or if you want to be independent. Let's go back in history and talk about a parable which originated in the Indian subcontinent, where there was an elephant which came to a village, and there were 6 blind men. They came in and they wanted to understand what animal is this, because they've never seen something like this. They can't see, they're blind, but never felt anything like this. But they came in, and each of those individuals tried to understand by feeling the parts of the animal what that animal might be. So for example, the one at the back thought that this probably is a snake touching the tail. The one at the trunk thought something else. And the side one thought that this was actually a wall. So it was a dilemma where everybody had their own objective opinion, passionately thinking that this animal actually is what they've seen before. What I'm trying to say is that every individual has a subjective belief system, or something which they have gained as they grow. And they might be absolutely correct in their own way, but it's something which is in silo sometimes. And how do we broaden our horizon and think of the bigger picture? For example, how would we know that this animal is actually an elephant rather than a snake? Let's jump into an example. I can't finish my talk without this example. In terms of the algorithm and the data science and how it's advanced over the last few years, you guys know that it can predict to an absolute accuracy. It can also influence some of the decision making which we do, or it can change the consequences of history. I think algorithms are really important. Data science as a discipline is really important for humans to automate certain tasks, to make us make informed decisions, to also make sure that we understand the nuances and the complications which human mind cannot comprehend. But in some cases, in some exceptional cases, there are consequences which can happen as a result. So you can create echo chambers where you might have certain mindset folks who actually get what they want to see, and then they take decision based on that, whether that's Trump, Brexit, or many other examples which might come in the next few years. Another example I have is a conversation between Jeremy Hunt and Stephen Hawking, which happened a few years ago, where there was a case for 7-day NHS. It was actually a very logical argument. And Stephen Hawking mentioned that the data which this company did to prove that we need a 7-day NHS was incorrect. And this argument actually I was passionate to talk about it, because it was actually gave me a bit more details of why that company made the recommendation that we need 7-day NHS. I don't think the recommendation in itself was wrong, but I think along the way, when they did the data analysis, they developed the model, they developed the algorithm. Somewhere in there was a bit of bias which creeped in, whether that was the input or whether that was how the data scientists build the algorithm. And that's what Stephen Hawking pointed out, and it was a fascinating debate where you could make an argument on either side saying both are true. And then there are examples which are more advanced than this, where some of the companies have done sentiment analysis to figure out what statements means. If you type a text, what does that mean? Is that a positive statement? Is that a negative statement? And there are algorithms which actually can predict with accuracy depending on what you type. And it's, in a way, it's sad that some of the statements which you type in, you get negative outcome. And the reason for that is data science and the virtual world we're trying to create, or the optimization we're trying to drive, is based on real world. We as humans have a belief system. We all think in a certain way. And when we developed a data science algorithm, it's not developed by machine, it's actually developed by humans. So it cannot be, it is factual, but the inferences from that machine is not factual. So how do we make sure that if the biases are creeping in, we solve it? How do we make sure that we don't replicate the class system or any biases which exist in society? Another example is an adversarial example where scientists were actually training a machine to learn from the images. So they actually threw a lot of images to the machine to understand whether it's a panda or a gibbon with 99% accuracy. So it was all well and good. The machine learned really fast. The algorithm was really accurate. But just as a test, they did some perturbation to the actual image. And slight perturbation to the image confused the machine a little bit. And what that confusion was, that it did predict panda with certain confidence, which is more than 50%. But in some cases, in some exceptional cases, it said that this is gibbon with more than 90%, more than 99% confidence. Now you would think, why is that important? This is just an image. It doesn't matter if a machine thinks that panda is a gibbon. Well, think of autonomous vehicles. Think about cars in future where you do slight perturbation to the sign, the road sign. What would be the repercussions of that? So as an example, this study was done as well. You have a stop sign, which is quite common in different countries. So it's very easy to model and say, if you see a stop sign, you stop the car. So very easy to code, very easy to predict, and very, very easy to take the action as well. But what if you do some perturbations and you actually can fool the machine? And that can happen. And not just these cases, but there are many other examples where you could fool the machine by doing slight changes to the image, or things which are really easy for human to spot. So if I'm driving a car, I would know this is a stop sign, as an example. So how do we make sure that when we train the machine, we build the machine in a way that it does not make decisions which are unethical from a perspective of human society? Or the other question could be, how do we make sure that we don't replicate the machine with all the biases which humans have? So we talked a lot about biases. Just want to give a high-level overview of what different kind of biases can exist. One of my favorite biases is the anchoring bias. So if I'm going to buy a new car, and I love BMW M3, for example, and especially in blue color, I have an anchoring bias that even before I go in and buy that car, I have anchored my view that I want the blue BMW, which is M3 sports model. So when I go and actually try and understand whether this, if I'm buying an old car, try and understand whether this would be a reliable car, I might not ask the questions I should ask, whether the engine is reliable or whether this car would last longer. But as soon as I see the blue car and it drives fast, I might get blinded and actually buy the car. And this happens a lot, not just in this example, but humans do that quite often. The other example is reinforcing your belief system. So say, for example, if there is a gun crime in America, both sides of the fence solidify their opinion that we don't need guns or we need more guns. It's reinforcing what you believe in by looking at data. So how do we make sure that if we are building an algorithm, it gives you the answer which not you want, but the answer which has a positive impact on the society, and it doesn't have any biases which you as a human might have. And that's another example where there's two sides of the opinion, where one of the image is clear to an individual where they thought that they had more crowd during the when they got nominated as a president. I don't want to debate on what side of the debate I am, but it's fascinating that both the presidents at the time in US looked at these images and derived different conclusions. And if you have a data scientist who could run algorithm on it, I'm pretty sure you could have a model which would predict A, the left side of the image had more crowd, or B, the right side of the image had more crowd. So as I said, people think that data is objective, data is factual, which is good. But how do we make sure that the inferences which we draw from data are factual? Because in some cases, they're not. Humans are really good at making decisions, by conscious decisions, because we are social conscious beings. We understand at a subconscious level what's right, what's wrong, but we're not really good at analyzing humongous amount of data at speed which machines actually can. So there's definitely a place for machines, and there's definitely a place for humans. So how do we make sure that they interact in a way where the biases don't creep in? We make decisions which have a positive impact on society, and they're ethical. So those are all good questions. I keep asking them because it's the last session. I want to make sure you remember what I'm saying. In the slides to come, I'll try and answer some of them. The other one is in data science, in some cases, you have a prior knowledge of what the model should look like, or you have certain competitive advantage compared to other companies, where it could be a bias which towards the solution, it could be a bias towards the competitive intelligence. So how do we make sure that whatever your belief system is, it aligns with the users of that system? So because at the end of the day, when you develop a model, or if you have predictions, you'll take some actions on it. Those actions would have consequences, or somebody would actually use it. So how do we make sure we look at our target audience and be more customer-centric? Now, I guess you're all waiting for a magical answer. How do we solve the ethical problem? How do we make sure the biases don't creep in? I've got some news for you. I don't think I have that magical answer, but I'll try and give you an answer which can apply in some use cases. Let's start with this hierarchical system. So I'm sure some of you are aware of the digital feudalism, or in the olden ages when you had a typical class system where you have a lord and you have people who are actual farmers and there are people who collect the taxes. In the current society, there's an element of it when you build digital applications. For example, you don't think of the consumers who use your data models in some cases. And that's where you are actually separated from the users of the system and people who produce the system. So if I'm a data scientist and I'm developing something for an e-commerce marketplace, and if I don't understand my consumers, I just collect this tons of data which gives me what, but it doesn't give me why. It doesn't give me why people think the way they think. It doesn't tell me why people go and book this flight on the website, for example. It just tells me an ID XYZ has actually done this. So I do get what from that data, and then I make certain decisions, which is good. But do I really think that these are customer-centric? Do I really apply my own decision-making and question the why aspect of it? So one of the answers where you can actually apply a bit more diversity in the data and try and remove as much as bias as possible is some of the levers. So if you're developing a data science model, ask yourself questions where, what is this model going to do? Why is this algorithm being built? What are the decisions we'll take out of this? And then these levers can give you some of the answers, whether you're trying to solve this for a society where you want to build a safer society. So you want to build an autonomous car which makes accidents zero. So it's more on the safety side of things. Or is it more authority, where you want to use that data socially and target on the Facebook users for a campaign election? So it depends on the levers you're using. You need to understand what impact it would have on the users who would see this as a result, or the prediction you will make. Will there be any consequences? Would people look at the campaign you're running and make decision by solidifying their belief system? Or would they look at the different side of the fence and try and debate the issue and say, hey, I believe in this, but I want to listen to other side of the argument as well? So these are some of the levers which you need to understand before you build a model, to make sure that there's ethics in there and make sure there's a bit of diversification. The other example is the use case example. As you know, as a data scientist, you build stuff for different use cases. So for example, you could build something which has a pivotal impact on the society, or you could build something which doesn't have any impact, but in terms of the decision making, the role of algorithm which influences the decision, it's massive. So you got to understand what impact does it make on this scale. And once you know what your use case is, it becomes easier to ask the right question. For example, why am I building it? What impact would it have? And is it positive? Do I have any biases creeped in, whether that's reinforcement bias, whether that's any other biases which exist in society? So asking those questions does help. And then in this slide, I want to show you how at every stage for a particular use case you could solve a problem. So for example, if I'm a data scientist, I have a perspective bias where I build this model in various other companies. So I know exactly how to do it. I know where to go for the data. I know what regression would work, and I know what results I need to focus on. So I already have a perspective bias as an engineer. So in this case, you need to diversify that bias. So have a team which is diversified. Have a team which have different opinions for a particular use case. The other example is having a data bias where you're focused, your frame is wrong. So for example, if you're collecting data to predict how many accidents can happen using autonomous cars, and your frame only includes San Francisco, where you're collecting data from people who are driving autonomous car in San Francisco. Compare that to driving a car in Southeast Asia, in India, or in Philippines. Would that still work? Would you still have an autonomous car in Philippines with that data which you've applied from San Francisco? No, because you have a framing bias. So how do you make it qualitative? Also, how do you make sure that it includes all the frames you want to include in? And then is your data explainable? So once you've collected the data and you're mining it, you've built a fancy pipeline, and you have a model which you've developed, can you explain that to a normal business user? Can you explain that to your stakeholder? If yes, that means you understand how you've developed it. Or is it almost like a black box where you've used something which is a library, and you know you'll get certain results from that library without actually understanding the nuances of what the applications are? And then the last one is your stakeholder tells you, just make it work. Just develop something because I need this tomorrow. So can you tune your data? Can you have a feedback loop? Can you make sure that the algorithm you're building is not developed in a way that you were so focused to do it in a certain time interval? And then lastly, as a result, you could either end up as a black box model, or you'll have more of a model with thick data. So by thick data, I mean you can answer questions if somebody asks why this decision was made based on the inputs I gave you, and B, you have some sort of diversification where you not only took your opinion into account, you also took somebody else's opinion to make sure what you've developed is diversified. So as data scientists, I think it's not just our responsibility to do all of this, but as a society, we're all responsible. If you're developing something, we need to understand what impacts would it have. So if you're working in a social media environment and you have Facebook, Twitter, or any other social media company, it's a collective way to solve problems. It's not just a data scientist problem, rather it's a society problem. How do we make sure that we all have this kind of oath where we focus on the impacts rather than focusing just on data? So here's another model which might work for certain use cases. As you know, like when you're developing an algorithm, you start with collecting lots and lots of data. You then try and train it. You develop it based on the source data you've got before you get the outcome or before you make any decisions. So one thing which, as a data scientist or as a business user or as a stakeholder, you've got to make sure that you ask questions. So for example, what factors are appropriate and fair? So if I'm developing an autonomous vehicle and I'm designing an algorithm for that, is the input variables I've taken into account, are they fair? Will they work in different countries? Or they're just focused on certain segment of people or certain cohorts which only you know as an individual? So how do you make sure that whatever you develop has a different lens to it as well? Another example could be, what are the ethical norms which exist within the framework you're working on? So for example, if you're developing something which directly impact certain cohorts, where they make the decision based on your algorithm. So for example, they see an ad on Facebook and they make a decision. Would that have any social consequences? If yes, what are those consequences? Are they negative, positive, or would that change the society as we know it? So how do we solve this problem in a holistic way? We need to all have a design thinking incorporated in every individual. So for example, if I'm developing something, I need to make sure that I understand the designing aspects of it. I'm sure in your organization, you might have seen some issues where you've got ethical issues within the data. If not, do you just work in silos or do you think the bigger picture? So how many of you just solve the problem given to you and never ask questions? So everybody asks questions if they've given any work. Is that fair? So you don't ask any questions, you said? No?
Depends on the work.
Yeah? So what would be the kind of work where you won't ask any questions? Sure,
Does that make sense?
it does make sense. Are you a data scientist?
Yeah, I study social data.
Okay,
So.
brilliant. That's good to know. So the point I'm trying to make is, in your respective organization, I'm pretty sure everybody has that challenge where you focus on your respective silos and you never take a step back and say, hey, this cool stuff I'm building, how would that impact the society? Or would it actually make human beings better? Would it also influence the things which I want to influence as an individual? Or does that align with my belief system, as an example? And the other example is where if you want to build something, you have to make sure that machine does the repetitive task better, and you as a human being do conscious things really well. You know consciously what's right, what's wrong based on what you've learned, but machines can actually churn billions and petabytes rows of data and give you decisions. But you need an interaction between humans and machines to make that decision better. You can't think of those two in silos. And I think the way data science field has evolved, it started as a research field where only a few individuals did it, and now it's kind of increasing with the pace that this is the right time to take a step back and understand what human interactions do we need if you're building a product. Does it influence a specific cohort, or what decisions would this impact? So for example, if I'm developing a machine which basically analyzes all the potholes in a village in America, and the way I'm building it is I'm looking at the tweets where people moan about the potholes in America. Would I be building it in the right places? No, because I'm relying on people who only tweet. I'm not relying on people who are offline, who don't complain about the potholes at all. And I can actually think of products which are just being built based on social data they could find on Twitter or social sentiment they've seen on the web, rather than understanding of the why aspect of it, for example. And here's the model which I think works really well, and this is part of the white paper, where it explains that you can't think of human and machines in silo. And during the stage where you build your data science model, you have to have the human complement machines, especially during the training, explaining, and sustaining the data. And an example would be one of the company in the US, Stitch Fix, where they recommend you clothing based on what you like. And throughout their process in the life cycle, they try and understand what humans like, what they like to wear from a fashion perspective, and they try and marry the human and the machine aspect together. So before they predict, before the recommendation algorithm work, there's a feedback loop which comes back to human to understand what is it that they like from a fashion perspective. And then lastly, as I said, it's not just the data science problem, it's not just your stakeholders' problem, but it's more of a collective responsibility. If we can build something, should we really build it? Or if you're building something, is this ethical enough in terms of the society impact which can it have? So as a whole sum, every individual has a responsibility to focus on things which has a positive impact. So ask yourself a question: if you could, would you, should you? And that probably would give you the right answers. Thank you. I'll open up for questions.
So if I shouldn't, because it's wrong, but the market will, what do I do?
At least ask the right questions. If you ask the question, somebody would think about it. And also frame that objectively, because if you're in a data field and you analyze something, you could frame that question objectively and say, hey, here's an example of what repercussions it might have. And it also depends on what the use case is, I guess. If it's an autonomous vehicle use case, it's probably be a stronger one. If it doesn't really impact the society that much, it's probably a different use case.
Hi, me again. So you kind of, when you kind of explain it, so you promote like a culture of design thinking in order to design ethically, but wouldn't it be better if industry standardized set processes to utilize data ethically? I wonder if you
so when you say industry design processes, do you have an example?
Yeah. So GDPR is a prime example.
I think GDPR is a really good framework in terms of the consent and providing that opportunity to the consumer, so the consumer is more aware of how the data is being used. But I think this lens is more focused on variety of use cases, where how do you make sure you're ethical in terms of building the products, not just like marketing that to consumers, but during the life cycle of building the products. I don't think there's a set framework yet, and I think there is an opportunity to have that framework right from the beginning. There are various frameworks which does a part of the job, but there's no overarching framework to say, hey, from the design part, from design to actually development to marketing, this is the framework you could follow. So yeah.
I've got a question based
Sure.
on the 80s film War Games, where the computer had to play noughts and crosses and then decided, actually, well, do you know what, going to war wouldn't be a good thing, and therefore I won't launch these nuclear missiles. So when will machines then be able to inference and make those decisions for us where humans get red mist and they see that red button, and then invariably humans will just destroy each other anyway, as we have been doing for the hundreds and hundreds and hundreds of years?
So that's a tough question. I want to make sure I'm diplomatically correct as well. So it's a really tough question for me. But I'm just trying to.
It's all fake news anyway.
Well, to answer your question, I think, to me, machines are not there yet. I don't think, because machines are developed by humans. So I don't think they're there yet where they're making an ethical decision versus humans. There's an argument that if you have senses in the machine, just like the senses humans have, then you might get smarter machines. And there's two schools of thoughts, as you know, like one is Facebook, Mark Zuckerberg has a school of thought, and then Tesla owner has a different school of thought. So it depends what side of the fence you are, but I like that debate because nobody knows the answer, but I don't think we're there yet. And I personally believe it might be really difficult to build a machine which is exactly like human or make that decision ethically, for example.
So following on from that, would there then be a United Nations Ethical Council where actually there is representation? Because if I'm not represented, but I think my ethics should be included, how does that happen for all human beings?
That's a hard question. I don't think I'm in. No, that's okay. I wish I was in UN or in some sort of political establishment, so I might be able to answer the question. But I guess I'm product owner, so it's hard for me to answer that question. Apologies. But good question, though.
Thank you. Just two quick questions. One is about having the process in a data science team where when you start a project, for example, in my team, we have a sort of ethical analysis before starting it. So how do you envisage introducing that? How can we promote maybe the introduction of this kind of assessment before we start a project?
Good question. I think that's where the product layer comes in, where the data scientist is so busy in figuring out the how sometimes, and we usually work with data scientists to provide the what. To me, that layer is product, where product people can ask that question when they're meeting the stakeholders, gathering requirements, making sure that during the life cycle of the project, data scientists and product folks kind of partner together to ask the questions I basically showed in one of the slides. It depends on the use case. I guess every use case might have different questions. But to me, like, product layer can help in that case.
Thank you. And very quickly, the other question is about, I've just been to a talk where the speaker was promoting an idea that in 10 years, pretty much data scientists will not be needed anymore because they will be substituted just by software. For me, it was a little bit unreasonable, from not only from the point of view of competence, like problem solving and so on, but what about ethics? And it's not the first time that I hear this, though. So do you have any comments on this? Have you heard, and how do you assess this?
The only comment I have is like AI, where if you've done certain things, it's no more an AI. So for example, 15 years ago, if you thought of Google Maps, that was an AI for people. Now we have Google Maps, and it's no more an AI. Maybe 15 years later, autonomous car would be normal, and we'll think of some other bigger problem. So what I'm trying to say is there's always an iteration. Nothing ends. Like, the people would come up something else to build, and then data scientists would then build that AI, if that makes sense. And as soon as that's built, it won't be AI anymore. Does that make sense? That's my belief, but I guess we'll see in future.
Quite an interesting talk. I was just curious, like, how is it? You said you were at hotels.com. So from using this framework, how, for example, on a particular, if you can share, like, how it kind of influenced the decisions you made, either positively or negatively, using this framework, it changed something that you were going to do?
Sure, I think we are very customer centric and we have a positive intent in whatever products we build. So based on that philosophy, as a product layer, we ask the questions throughout the life cycle of the product, as in, is it customer focused? If yes, how? And then also having a positive intent throughout the life cycle. And it depends on the use case, I guess, what you're building. So I've given some use cases in the slides.
Hi. So if I understood your talk correctly, your recommendation seemed to be that we should be asking ourselves ethical questions when we put things into production. Do you think that's enough, or do you think it's necessary to have places like, say, the Future of Humanity Institute doing research specifically on AI safety, which includes things like ethics and bias?
Absolutely. I think this field will only going to get bigger because the human-machine interaction is something new. Like 15, 20 years ago, people would not talk about ethics between human and machine. But as we build more and more products, I can totally see value of like having some sort of central committee which builds framework. But my only challenge to that would be there's no one framework which would work for everything. So it depends like what you're trying to build. But definitely this field would gain more traction as we build more products.
Is there any work being done to kind of take ethical codes and make them kind of machine readable so they can actually start to kind of feed into the algorithms and guide them themselves?
So I know some examples, but I don't think they're effective yet. But yeah, I'm not aware of like really effective examples. Are you? Like, do you know any? I don't think so. I know like some of the companies, like without naming companies, they try to diversify the data to make it more ethical. But as the bot learned more and more, it then kind of formed the way society thinks. It kind of formed into that belief in thinking. So I think it's been a challenge. But yeah, I guess as you mature more and as the human and machine interaction increases, it is a possibility.
Any last questions? Cool. Big round of applause for Satya.
Thank you.